Hello, Natalie from Natematics here. I'm going to be going through a number of algebra questions that are aimed at foundation level students. And when I say foundation, I want to make this really clear. This is foundation level for England. So we're talking about AQA, Pearson Edexcel, OCR, IGCSE as well, foundation level. And also these will be applicable to students doing the intermediate WJEC. Also higher level. Now, what happens in higher level is obviously some of these skills are built on. So it's always really, really important that you make sure that you know the basics. So do you know what? This is really applicable to everybody. Although some of them on the WJEC foundation level won't have to do all of these, but they'll be doing, a few of them. They are in no particular order. And this first question is one that normally says expand and simplify. Now, it's words, don't they? These words are really important in maths. I often get asked, well, why do we need to know about words? It's maths. There is this overriding thing that maths is numbers. Yeah, we use numbers in maths. However, there's a lot of problem solving going on. There's a lot of things that have meaning, and we need to make sure we know the meanings of those words. So expand means we're going to have to make something a bit bigger. Simplify means we may sort of have to reduce maybe the number of terms. We may need to kind of cancel down, i.e. divide by a common factor. So those are typical things that you would have with the word simplify. Right, so we have here in brackets 5x minus 2, and then brackets outside, and it's number 2. The brackets mean that that square applies to everything in that bracket, not just the 2 at the end. Make sure you look where your brackets are. So what does 5x minus 2 mean anyway? And I'm sure some of you probably thought that yourselves over time. Well, basically, there is a number that we don't actually know the value of right now, but we know that there is something that is multiplied by 5, so that's where the 5's in front, and then we take 2 away. There are lots and lots of rules that go on behind the scenes in our laptops, our phones, in software, in various games, etc., where it does a calculation, and then it applies that calculation to normally something that is input by the user, by you, the game player, whoever. Okay, just a brief thing about algebra there. So squaring, what do we know about squaring? Now I'm just moving, obviously, at the moment. My little window with me is in the top right hand corner. I'm watching it now, obviously I can read it. So what does it mean when we are squaring something? This is a very, very key question to ask yourself when you get questions that you're not quite sure what to do with. What do I do when I square something? Don't worry about the detail here for now. Obviously, if you know what to do, go ahead and do it. This is aimed at those who are perhaps looking at and thinking, not quite sure what to do. So what do we do when we square something? So, well, what would I actually do if I had actual numbers? That is another really, really important question to have in your bank of questions, or what I might call my Natalieisms. What are the things I ask a lot? Okay, so let's have a think. If you can't remember, like 2, 3 squared. Well, what does 3 to the power of 2 mean? Multiply by itself, not times by 2, multiply by itself. So whatever is underneath or to the left of that 2, we basically write it out again, put a times in the middle to make it super, super simple. Okay, let's try another number. 10 to the power 10 squared. I obviously didn't put the square in there, but 10 with the invisible 2 is 10 times 10. One of the skills I work on with Key Stage 3 students is I'm not interested in the answer. Obviously, the answer is important. We'll deal with that later. However, I'm interested in how you got there. So when you square something, I take whatever it is, and I put it straight after it. I stick a times in the middle. Okay, so let's apply this method to this number. I don't know what this is yet, but I know there's some number times by 5, and I take 2 away. So have I there done what that squaring function does, that squaring mathematics things does? Yeah, I have, because I've said, oh, I want this whole thing here and multiply by it, and I need them to multiply. Natalie, you've not put the times in the middle. It's okay. In algebra, we don't show it. It's okay. So I might have put that extra step in, but I haven't. Right then. So what do we do when we have 2 brackets together? Another Natalie question, another thing to take note in your revision. I've got 2 brackets like that, and I've got 2 things in them. What do I do? There's a few ways we can do this. I have applied the smiley face rule here. You may just do it automatically in your head. You may use FOIL, first, outer, inner, last. You may use the grid method, 5x minus 2 on one side, 5x minus 2 down the side. As I say, I've done the smiley face one. It's one that I know a lot of students recognise, because this whole thing, eyebrows are obviously a key thing in today's society with your makeup and everything. So anyway, 5x times 5x. I always say break it down into letters and numbers first. So 5 times 5 is 25. And then you've also got an x times an x. So that's x squared. Kind of going the opposite way, aren't we, to what we did with the brackets. Right, that's one eyebrow, okay? Most of us have 2 eyebrows, so where's the other eyebrow going to go? There you go. I mean, they do cross in the middle. Just a minor thing, don't worry about it, just ignore, okay? But yes, we have 2 eyebrows I put in. So we've got a minus 2 times a minus 2. Look at the numbers first. 2 times 2, 4. A negative times a negative gives you a plus. One to remember, okay? It was something that, yeah, and then minus times a minus, negative and negative comes a plus when you multiply. However, somebody gave me the visual and I was like, oh, I never thought of it that way. So I always tend to do it now. Somebody's struggling, I'm like, a minus and a minus. It's like, oh yeah, it does that, doesn't it? All right then, so we've got 2 eyebrows. We also have a nose in the middle, don't we? So where's that going to go? Minus 2 times minus 2 multiplied by 5x. What method did I use earlier on? We've got, let's look at the numbers first. 2 times 5, 10. We've got an x, but there's no x here. So it's just one x. So we've got 10x so far. And then we've got a minus, and then there's nothing there, so it'll be a plus. There's nothing in front of it, it'll just be a positive number. So a minus times a positive number, a minus times a plus. They're different, negative. So minus 10x. So we've had eyebrow, nose, big smiley face that I generally have on my face when I'm tutoring. So yes, 5x times minus 2. What are we going to do? Numbers first. 5 times 2, 10. Is a positive number times a negative number. It's negative. We've got a letter in one. We've got x in one, nothing in the other one. So it's just x. So there we go. So we've got 25x squared. So this number I don't know. I'm squaring it. Then I'm multiplying by 25. Then I'm going to subtract 10 lots of this number I don't know. I'm going to subtract 10 lots again of this number I don't know. And then I add 4. I'm just kind of reading out loud to give you that extra value added. Yeah, loads of value added from me. I'm giving you a bit extra today. So another one of my little questions is, what maths can I do with what's in front of me? So at every point, always look at what you've just done. And is there anything that you know you can do to that? So we've got a minus 10 there. I thought I'd highlighted it, but obviously I didn't. You've got a minus 10 and a minus 10. Now you're not multiplying here. There's no multiplication sign there. It's literally you're at minus 10 and then you're subtracting 10. I would say when you're adding or subtracting, look at your first one. That tells you where you are on your number line. The next one tells you which direction you're going in. So here we're subtracting 10. So you're at -10 and you're getting smaller. So you go into -20. And that's that there. And there you go. Right, I'm just going to pause now and I'm going to come back to you in a moment with another one. Thank you very much. I am now going to stop recording and go back into another one. Okay. Here we go now, as promised. Here's your next question. So we have algebra now. And again, this is still from IGCSE paper, a foundation level. So we've got two questions, again, with two different words. We have a simplify, and then we have a solve. Oh, didn't have that one in the last one, did we? So remember what simplify means. Simplify. We always say when we simplify something, we make it easier, don't we? It's almost like, Natalie, can you simplify some maths for me? Make it easier. In the context of algebra, just another little reminder, you are condensing things together. Simplify. Now you see, just look at this, and I want you to just read out loud in, if you can, or write it, kind of think it in your head. Can you just read this out for me? Okay. So I'm now going to give it to you. So if you want to just pause, have a go, and then press play again. So this is, we've got 10 lots of some number, I don't know. I'm going to add to it 4 lots of another number, I don't know. So it's a different letter. I'm going to add to that 3 lots of, first the number I had before, because it's X. And then I'm going to subtract 6 lots of that second number. Okay. So you can see that there are 2 terms that are applying to the first number, X. And then there's another 2 terms that are applying to that second number, which we've called Y. So when we simplify, it's like collecting like terms. By like terms, we are talking about these X's and the Y's. So 4Y is a term, 10X is a term. So what we're doing is, I always say, like, look at the things that are the same. So they have the same letter, and the power to that letter is the same as well. Because sometimes you might have an X, you may even have an X squared in there. And in the lesson I've just done, the question I've just done before, notice I didn't combine the X squared, the 25X squared, with the 20X. Because X squared is a different number to X, isn't it? There's only one case where X squared would be the same as X. What number would make that happen? Just a little teaser for you later on. If I don't respond, if I don't tell you at the end, I'll tell you another time. Right, so what I suggest you do is get these things, get your highlighters, and highlight the ones that are the same. So for example, here we've got 10X plus 3X. Now, I kind of do these slightly differently, or I'll highlight different things in different ones that I do. So here I have not kind of written the 10 and 3 together at all. I've just said, right, there's 10X and there's 3X. So that means we've got 13 lots of this number I don't know. Okay. Then we're going to look at the other one. What else have we got? We've got a Y. So we've got 4 lots of this Y. And we have to take away 6 lots of that Y. This is where you say, but why do we need to do it, miss? Yeah, funny. 4Y, take away 6Y. So start at 4. Think of your number line. You are taking away 6. Think about which direction you're going to go in, left or right. Some people visualize a number line vertically. I couldn't think of the word then. So it's like when I take away, I kind of go up, go down. When I add, I go up. Entirely which one works for you. But ultimately, we start here, -4, and then we're going to take 6 away. So we're end up at -2. One thing I do quite often mention on here, I haven't done it on this particular animation, is sometimes if the first term is negative and the second term is positive, what I suggest you do is swap them around. So for example, if I had, say, minus 6y and I had plus 4y. If you find that you tend to get a bit mixed up with your negatives and positives and taking away, etc., it often helps if you put the positive one first. So rather than having the minus number and then the positive number, just swap them around, but make sure you take the sign that's in front or to the left of your term when you're moving it around. One of the most common mistakes I see on this is that you forget that that plus belongs to the 4y. So when you think of when I'm looking at those terms, I'm looking at the sign before on the left, okay? Remember that. And you'll notice how I've done that here visually to show you. Okay. All right, then next word, solve. Solve. What does solve mean? And, you know, some people will say to me, it's the answer. You get the answer. No, I'm a mathematician. I'm a statistician. I'm a maths teacher. I need a bit more information, okay? So when you say to get the answer, what kind of answer? What problem are we having to solve here? So basically, it says that two lots of some number, add 5, make 16. Okay, so there's this number, I don't know what it is, and I could probably do it by trial and error, and I could kind of work out that it's 5.5. Yeah. However, I need a method, because sometimes that working out that number in your head is not always so easy. So think about your method that you're going to use. So I have a video that I do where I go through solving equations, and it's part of my Pass Your Maths course. It's an 8-week course that I will be doing after the results come out in the summer, because then that prepares students ready for the resits in November. So basically what we're doing is solve. I want to know what that value of n is that makes the left-hand side exactly the same as the right-hand side, okay? So I need to strip off everything around that letter N, so that all I've got on the left-hand side is N. So I've got 2 here, and I've got a plus 5. Now you kind of have highlighted the N. Sometimes I highlight the other numbers. Depends on my mood, okay? But ultimately, you have to remove everything away by kind of cancelling it, okay? We're not just removing it and forgetting about it. We have to do it in a mathematical correct way. So we're going to get rid of that plus 5 first. So we're going to strip the plus 5. The 2 is attached to that N. They're very close. They're best mates. You know, you don't want to separate them just yet. You keep them together right till the end. Do you know what? That might sound totally ridiculous, but you know the number of people who it then makes them helps them to understand what's going on. And you know what? If it helps, I will come up with all these little analogies. So here we go. So we're going to get rid of the 5. How can I get rid of the 5? Don't get Tipp-Ex out. You do the opposite to what adding 5 is. So what would I do? What could I stick on the left-hand side, which would then eradicate that plus 5? There you got the answer on there now, haven't you? We take away 5. So we end up with, on the left-hand side, 2n. Sometimes students forget that when I'm doing that kind of adding or subtracting on both sides or dividing, etc., that I'm doing it with the sole intention of cancelling out one of those letters. At the end of this, there's going to be I'm going to be doing probably a grade 5 level solving equation where we've actually got a denominator in there. It's a fraction. So believe me, these get a little bit harder. However, just remember, what is it I'm looking to move, so that when I actually do that calculation, i.e. take away 5 from both sides, that thing that I was looking to remove has gone, okay? So on the left-hand side, plus 5's gone. On the right-hand side, you've got a minus 16 there to start with. So it's still there. You know, we've not touched that. However, what we're doing is we're taking 5 away. So if we're taking 5 away from 16, what have we got left? We have got left 11, and a nice little equal sign in the middle there. Okay. Now, again, you can probably look at that. Yeah, I know the answer. However, I want a method. What would I do to get n equals something on that left-hand side? I'm gonna have to get rid of that 2, aren't I? Now, the 2 and the n are together, but you know what? We're gonna have to separate them now. It's okay, you know, I'm sure they can see each other in another life or another question. So I laugh, but I say, I'll remind you, it helps people remember. So 2n equals 11. 2 lots of a number I don't know equals 11. So to get that n on its own, I've got to get rid of that 2. What's that 2 doing to the n? It's multiplying it. Remember, in algebra, another little tip for you for your revision cards, etc. 2 times n, 2 lots of n. We do not show the times between numbers and letters in algebra. Okay, so 2 lots, so we're multiplying. How do we cancel a multiply? We do the opposite, which is a divide. I'm fired up today, you know. I think it's because I'm going to reel as many of these out over the next few weeks. And one of my students said about solving equations. I thought, right, okay, I've got stuff here ready, just got to record it. So we're going to divide both sides by 2. So 2, lots of n, divide by 2, you're just left with m. And then on the right-hand side, you've got, I've put 5.5 in there. I've put it as a decimal. What other ways could you do? I know some people who, you know, struggle with algebra a little bit say, well, actually, I can't do 11 divided by 2. You can divide any number by any number, really. Except 4 divided by 0, you are going to get an error. But you can divide any number by any number. If you've got a calculator, you do it, 11 divided by 2. If it's not a calculator paper, set it as a fraction. I'm pretty sure I've got a fraction as an answer on the next question I'm going to show you, or at some point on this thing. Or you can cancel it down. So 5.5, 11 over 2. How many 2s are there in 11? 2, 4, 6, 8, 10. I use my fingers too. So we've got 10. Can't quite get to 12. Can't quite use anymore because I'll go over the 11. So 2, 4, 6, 8, 10. 5 lots of 2 and 1 left over, which goes over the denominator, which you've already got, which is 2. So 5.5. There we go. Right, so I'm just going to put this onto pause, and then I will see you in the next question. Bye-bye. Hello. I thought I think I was recording then, but clearly I was. So you'd have seen me flicking through the left in the lesson. So if I actually get around to it, I'll probably get rid of that little bit in the middle, but that's okay. This next question is a factorise. Another word, isn't it? Factorise. What does factorise mean? I've had solve, I've had simplify, I've had expand, I've had, yeah, what else have I got to do? Factorise. What does factorise mean? What word is it similar to that you come across in maths? Well, factorise is similar to, it's an extension of, I think there's probably a posh word for it in English that I can't remember now. I don't have to teach that sort of stuff anymore, so I don't look at it myself. Factorize. When we're going to factorize, we have brackets, okay? Factorize means brackets when it's algebra. Also, factor. What's a factor of a number? So a factor of a number or a letter is what can divide into it. So say you've got 10 and you divide 2 into it, you get a whole number of 5. You get an answer of 5. So 5 and 2 are factors of 10. Okay, so what do I multiply something by to get that answer? Okay, so here I'm going to look for, we need to look at common factors. But as always, when we have things like this, we break it down into letters, numbers, and then also the sign as well. So it doesn't kind of look so scary, you know, to start with. So one tiny step at a time. So let's have a look at 15 and 20. What factors do 15 and 20 have? Well, 5 is a common factor. Are there any other common factors they have? Except for 1. No, so 5 has 1, 15, 5 and 3. 20 has 1, 20, 2, 5. We got 4 and 4 as well. That's it. 2 and 10 as well. Try and do it in my head. Okay, so we know 5 is a common factor of the numbers. So let's have a look at each letter now. So we've got a Y, haven't we? We've got a Y here, some number, I don't know. And I've also got a U, another number, I don't know. But these Ys, if they're in the same question, we assume that this value Y here is the same as that value Y. Okay, it's just that it's to the power of 4 on this one, and the other one, it's the power of 3. So looking at those terms here, we've got Y to the 4 and Y to the power 3. So what we do with letters is when we say Y to the power of 4 is Y times Y times Y times Y. So we could just do that. You know, if you weren't quite sure, you thought, right, okay, I'll expand it out to help me. And then Y to the power of 3 is Y times Y times Y. So if we were to write Y times Y times Y times Y to the power of 4, how many lots of Y times Y times Y times Y could we get out of it? There'd be 1, wouldn't there? Yeah, so we can divide one into the other. So basically what we do is we pick out the lowest power. That is your highest common factor for that particular letter. Okay, so as I say, we look at the Y's and then we look at the lowest power. And then we've got U's, haven't we? But then there's no U. There's no common factor in both of those numbers with a U in it. So U is not common. So we've got our common ones here. So 5 is a common factor there. Y to the power 3 is a common factor here. That goes outside our bracket. We then open our brackets. And then we say, what must I multiply 5 to the power of 3 by? Sorry, 5y to the power of 3. The 5 isn't to a power. To get, first of all, 15y to the power of 4. And then plus 20 y to the power of 3. Do you know what? I know there's letters there and it's like, oh, lots of letters mean scary. No, it doesn't. No, if you keep thinking letters are scary, algebra is scary, algebra is hard. If you keep telling yourself that, guess what? Your brain is going to think, oh, can't be bothered. You know, we have to give our brains, we have to coach our brains. Our brains need a bit of encouragement, okay? So while I'm here and I'm talking about this, I want you to kind of just say algebra is, you know, it's just a series of rules. It's just a series of rules that I've learned to do with numbers. And I just do exactly the same to the letters. And it might, you know, there's lots of letters. When we do things like equation of a straight line, there's like y equals mx plus c. Y, M, X, C. 4 letters in one little equation. Once you know what they all mean, it becomes a lot clearer. Anyway, I shall go on. So 5, we're going to look at the numbers first. So 5 times what makes 15? So 5 times 3 will make 15. Y to the power of 3, y times y times y, 3 fingers, times another y, 4 fingers. I've just swapped them because it's easier to hold up, makes y to the power of 4. Next thing is, let's have a look at this one. So we've got 20 y cubed with the times in the middle of each of those. So 5 times what makes 20? And then, well, I've got 20 y cubed, but I need a u in there. So when I multiply it out, I need to make sure I've got my u in there. Now, I created these. I've been putting all of these together quite conscientiously, I think. I've done loads over the last few weeks, last few months even, and it's good to just get them recorded, really. Now, I never quite know what's coming up. I can't remember if I added in, oh, what do we do if we want to check it's actually right? And there it was, a little text box there. So how can you check that this is the correct answer? I'm going to share with you a little bit of an experience I had with maths. I've been doing maths all my life. You know, I've been a statistician. I did my degree in maths. I've done lots and lots of stuff with maths. Even when I did oops, I seem to have gone to a different window. Hang on a second. Hang on a second. I'm just going to go back to where I was. There we go. No, not that one. Is it that one? There we go, back again. I'm going to be editing a few bits of those out, but for the student I want to send this to, it's okay. You all know what I'm like. So what was I going to say? Yes, so when I did I had to apply to be to go onto the PGCE course for maths, which is a postgraduate certificate in education. And to do that, you know, that's the thing that gives me that qualification that allows me to teach in secondary schools as a maths teacher. And believe me, maths teachers who are mathematicians, those who have had that high level of education in mathematics, very, very much in demand. And one of the things I had to do as part of my interview to get on the course was to do a GCSE maths paper. And it was a higher level paper. And I had to make sure that, you know, because I know how to do it, I knew how to do it. However, I know that if I don't do things slowly and I try and rush through it, like, oh, I know this, I make mistakes. So I went through every single question. I did it super quick, as you would expect for somebody who's got that experience. But I made sure every single step I checked. So, for example, I factored it. I'd say I factorized a question. I then did the opposite, i.e. expand brackets out. Okay, so remember, if we've got brackets, and if you see something in a question like this, whether it's halfway through your calculation or if it's, you know, part of the way through, or it's at the end, or maybe it is the question, what do I do when I've got something outside brackets? Well, you've got big maths for a start. So you deal with brackets first. Here, can't do much with this anyway. But always remember these little techniques, excuse me, that you have. So we can multiply that by that. So 5 times 3 is 15. That's fine, I need a 15, good. Y to the power of 3, y times y times y, times by y. There's another one, so it's y to the power of 4. Yay. Then the next thing is 5 times y to the power of 3. Bit of a mouthful, aren't they? So we've got 5 times 4, which is 20. I've got y to the power 3 and a u, so that's u y to the power 3. Yes. So just little things like that, that when you've done, maybe you just want to, sort of 5 minutes before the end, maybe 10. If you think you finished early, go back over some of the questions that you've left out maybe and thought, okay, what can I put here? Because I know the examiners want to give me a mark. So I want to make sure that I put on that paper, I kind of know the method, or I think it's this. I'm not sure, but you know what? If it means that I don't have to do this again, or yeah, think about that. So what I'm going to do now, as always, I'm just going to start pausing it. So I'm just going to pause recording, and I'm going to find. This is the solving equations question that I was talking about earlier on. So this is, I would say, grade 5 level, grade C/B, if you're WJEC. So I have got this equation that says 4 minus 3 lots of some number, I don't know. I know it's equal to 5 take away 8 lots of this number, I don't know, the same one, because the letter's the same. And then I divide that on the right-hand side by 4. So if I knew what x was, I could times it by 8, and then take that number away from 5, and then divide by 4. But here, it's asking me to solve. Show clear algebraic working. What that means is you cannot just sort of sit there for 5 minutes and think, right, well, if x is 2, I've got 4 minus 6, which is minus 2. If I put that number in on the other side, do I get the same answer? No. You will have to show some form of method, and that is exactly what I'm going to go through with you now. So the one earlier on was what I would call a two-step equation. If I talk too quickly, which I generally do, I trip over my words, and that's okay. It happens. I get over it. So this one, two-step, means there's normally something multiplied by a letter, and then you add or subtract something to it, maybe. Here, I would say, is more of a 4-step equation. Look at your equation and see, are there any denominators in there? Okay. Now, just as a reminder, solve means we want x equals something. So we kind of need all the x's together. Yep, that's fine. We'll deal with that later. But we've actually got a fraction here, haven't we? So we've got something divided by 4. So what I say is, if you have something like this, get rid of it as soon as you can. Okay, and this is where I'm talking to foundation level. If you're doing higher level, really depends on where that divide is. Yeah, in terms of the stages, but in terms of the levels that you get for foundation, you normally can kind of get rid of that fraction to start with. So how do we get rid of a divide by 4? No, not tip X, not a white pen. You're not allowed to rip up the paper either. What other answers you're gonna give me now when you're watching this at home? But you do the opposite. Do the inverse. Divide by 4. The inverse of that is multiply by 4. We do it to both sides. Why? Because we know that 4 minus 3x is equal to 5 minus 8x divided by 4. If I multiply one side by 4, it gets bigger. So we're going to have a bit of, it's not going to work anymore. As long as we apply the same rule to both sides, you've still got that balance going on. And as I mentioned in an email I did on Facebook last night, life's all about balance. Connection there. Anyway, multiplying by 4 both sides. So let's look what we've got then. So I show, when it says show clear algebraic working, actually show what you're doing. Write it down. So then I'm now just going to deal with the left-hand side. So I'm multiplying this by 4. put your brackets in. Yeah, remember, I'm always very open and honest about my own mathematics practice. I know that if I don't protect things, I end up kind of like, especially if you're doing a question and you think, I might have to come back to that later. Make sure that you've kind of left it at a point where you know you've not forgotten anything. So here we're literally saying, well, it's 4 lots of everything 4 minus 3x. Because remember, this is a number. Whatever that number is, we're multiplying by 4. So put your brackets around it. And then on the right-hand side, why did we multiply by 4? Because we want to remove that denominator. Yeah, we want to cancel this out so that we only have a single line. There's no fraction to be seen. I think I did this on one of the earlier questions. I said, remember why you're doing each step. So the whole point of times by 4 is to get rid of that bit. So what we've got is this left at the top. So, and I always say, well, what's at the top? What's there on the other side of the equal sign? Are we doing anything to that? No, just cancelling the 4 out, and that's okay. Right, so what maths can we do with what is in front of us? So I've got this now, and we're like, okay, so I've done that bit. Got, multiplied both sides by 4. That'll be my first method mark. So, well, I suppose I could expand those brackets, couldn't I? So I'm going to multiply those brackets out. I thought I got rid of those arrows, but obviously not, it's fine. So we've got 4 lots of 4 and 4 lots of minus 3x. 16, take away 12x. And then on the right-hand side, we've got, just leaving that as it is. But we, again, replicate everything that's in the row above, but applying this, whatever it is, to the bit you need. So multiplying out those brackets on the left. Right, so this is now at the point where we've got these x's on both sides. Could be y's, could be any letter. When you have got on both sides here, so we've got a minus 12x, minus 8x. We look at the smallest one, i.e. the number in front, coefficient. So we've got minus 12x and we've got minus 8x. Which one of those is the smallest? And take care. It's the minus 12. Remember on your number line, minus 12, you owe somebody £12. You owe them more money. You owe them more money. So effectively you have less money altogether in theory. So you owe, and I'm trying to think of the best way to explain it, but minus 12 is much, much smaller than minus 8. Okay. So to remove a minus 12, we add 12. But we're not just adding the 12, we're adding the whole thing. So we identify which one's smaller, minus 12, minus 8. And then we add, or do the opposite, to both sides. So to cancel a minus 12x, we add 12x. Always to both sides. Show the examiner what you're doing. So on the left-hand side, well, in theory, that's gone, isn't it? So we're left with 16 on the left-hand side. And then on the right-hand side, we've got 5 on its own. And then we've got 8 lots of this number I don't know. And then I'm adding 12 to it. I'm adding 12x, 12 lots of this number I don't know. But I've got minus 8 to start with. I'm adding 12. So in theory, I have got, I actually put the step in there clearly. I'd forgotten I'd put that extra step in there, which is fine. So what maths can I do with that? Well, I've got minus 8x plus 12x. They're the same. Group them together, minus 8, add 12. You end up with 4x on the right-hand side. Plus the 5 you've already got there as well. And the 16 on the other side. Something I don't think I've mentioned in this whole video that I've been putting together is that you can't combine these. You can combine them if you knew what x was. So if you had perhaps an equation and you were substituting in a value of x, then you could simplify it better. You could combine it. But when we're solving an equation, when we are factorizing, when we are collecting like terms, we're only adding or subtracting things together. You can't kind of just combine a 5 and a 2x because we don't know what the x is. However, we can multiply them. Anyway, if that's caused a little bit of confusion, perhaps just go back over this video again and you'll see the steps, because there's quite a lot in here. Okay, so if you remember that I did a question with 2n plus 5, I think it was, or 2n minus 5. It's very similar. It's what we call the two-step equation now. So you've got the number, the thing I need to find, because I'm solving. Just a quick reminder, I need x equals. But on that side of the equals sign, I have got a 5 and I've got a 4. The 4's attached to the x. Keep them together. Keep them happy. I don't want to strop off them. I want to get rid of the 5 first. What's the 5 doing? It's just sitting there and it's got nothing in front of it apart from the equal sign. So we assume positive 5. To cancel a positive 5 out, we would get a negative 5. And when I say cancel as well, something to bear in mind is that what can we do to that to make it 0? That's another way, because when I'm in a lesson and I'm interacting with a student over their maths and what have you, obviously they can ask me questions. I haven't got anyone asking me questions here. I'm talking straight to my computer, all on my own in Natematics HQ office. And so I'm always thinking about things that I want to sort of make sure I say. So look at the left-hand side. 16, take away 5 is 11. Look at this side now. We've got a 5, take away 5 is 0. And then we've got a plus 4x, and that's still there. So we just need to show that there. Nearly there. So we've got 4 lots of this number, I don't know, is 11. What is my number? So what I need to do, and I thought I'd put in an extra build there, it's just in the wrong order. That's okay. So I want to get x on its own. The 4 is attached. I'm going to have to separate them. So how can I make that 4 disappear? So, I'm going to have to divide both sides by 4. So on the ends, you can come in, Caris, you've got 4 divided by 4 is 1. It's just exercise. Caris wants to go out, so she's waiting for me to go out. And then we have 11 divided by 4. And I'm just going to leave it like that. We saw on the other question, I actually did a decimal, didn't I? Here, I have just left it as 11 over 4. So always remember that line between the numerator and the denominator means divide. So you can show a division
Divide's just the symbol for fraction, isn't it?
In theory. Yeah, it is.
I figured that out a few years ago.
Caris, my daughter, who's just adding, those people who don't know, my daughter. When you look at your divide symbol, you've got a dot and then a line and a dot. So you can just think what those dots, they're the numbers. So it's a number on the top, a number on the bottom. So just make sure at this point that what you have to give your answer in. Because across your exam papers and across any questions you're doing, there will be certain things that you are being tested on. So is that I know how to turn a mixed number into a top-heavy fraction or improper fraction? Do I have to convert that fraction into a decimal? For the person that I'm doing this for now, but obviously other people will see it, you're doing IGCSE. So I am just going to remind you how to do this. So let me get a pen so I can point to you on the screen. You have a button here. In fact, I'm going to stop sharing. I'm going to put this on here so you can see. Oh, it's very nice. I'll show you. Caris has just drawn me a little picture. I'll share with you in a moment. So I always find this really disorientating, so I'm having to do the opposite. Okay, here's your fraction button. Look, that one there. So you can see I've input 11 over 4. If I type in, if you look at your S to D button, oops, hang on a minute, Shift S to D, oops, hang on a second. I did this the other day. So if I put my fraction in and I click on equals, so you'll see it comes, I need practice on this, it comes on there. If you look at Shift and the SD button, which is there, again, I'm having to go in the opposite direction, it turns a top heavy fraction, improper fraction, into a mixed number. So 11 over 4, basically we're saying how many 4s are there in 11? So 4, 8, again, using my fingers again, 4, 8, 12. I've gone too far. So I've got 2, and I have a remainder of 3, and that 3 goes over the denominator that I've already got, which was a 4. I am going to stop this now because obviously I've got other things I want to do, but that little video hopefully has given you a good grounding of, one, what the different words mean in algebra, different skills, but also looking at them in lots of different ways, and boosted that confidence for you. I will be recording a few more in a bit, so I'm going to leave this to compile now, which basically means it's saving it to the laptop, and then I can upload it to send to you later. And Caris just came into the room. Come and say hello on the screen, and she's just drawn that little picture. Isn't it lovely? So there we go. That's what she was doing. She normally draws a little smiley face, don't you? Don't do a little smiley face on it. No, it's all right. Anyway, I'm going to stop this now. We are going. Caris has partaken in some education, haven't you, darling, this morning? She sat and did an exam paper at home, which is very good. And yes, we are popping into town now. So bye.